Welcome to another mathematics lesson. My name is Kingsley Linus. In today's lesson, we'll be considering the topic counting in base 2. By the end of this lesson, you should be able to define number base. Secondly, you should be able to count in groups of 2. And lastly, you should be able to express base 2 numbers in the powers of their base. When we talk about counting in base 2, it is very important to know what counting is. Counting is simply the process by which we determine or identify the members of a given finite set of objects. When I say finite set of objects, I simply mean a group of objects that can be counted. Note that counting is important because it enables us ascertain quantitatively the value of things or a group of objects. Numbers can be assigned to objects, animals, as well as humans. For example, a team of footballers, each player can be identified by their numbers. So, counting makes identification and accountability easy. Our topic is counting in base 2. So it is very important for us to find out what a base is. A base is simply a foundation or a platform. Another word for base is radix. Now, a number base is simply a foundation on which we count, measure, and calculate things. Our focus here today is the base 2. Counting in groups has to do with the number of available blocks we have whenever we count a set of objects. What do I mean? Certain things come in certain numbers. For example, a crate of eggs has 30 eggs. The days of the week are 7. So 7 days make a week. 60 seconds make 1 minute. Now, 30, 7, and 60 are the number base we use when counting these objects. There are several number systems, but the decimal number system is the most common. The decimal number system has 10 unique digits, 0 to 9. Also, we have the binary number system. The binary number system is a number system that has 2 unique digits, 0 and 1. This binary number system has been found to be very helpful in the world of computers because it provides an easy way of storing information. There are other applications of this binary number to the computer world. That is not our focus today. We are going to be looking at how we can work or calculate using this binary number system. In the binary number system, we count in groups of 2s. Now let's look at how a number can be represented in the binary number system. The binary number system has what we refer to as place value. That means each digit has a value based on its position. Now, the number 11011 in base 2 can be represented as shown here. The first digit, which is this one, comes under units. That is 2 raised to power 0. The second digit comes under 2s. That is 2 raised to power 1. The third digit, 0, comes under 2 raised to power 2. That is 4s. And the fourth and fifth digits as well come under 2 raised to power 3, that is 8, and 2 raised to power 4, that is 16th, respectively. So this is how we represent this number 11011 in base 2. In expanded notation, the number can be written in this manner. Now, I have an illustration. If, for example, we are given 19 apples and we are expected to group them in twos, here is how we can carry out this activity. Here you can see I have a bowl containing 19 apples. From my previous explanation, the closest place value group we have to the number 19 is 16. So we can group our first 16 apples together. And then we are left with 3 more apples. So from 3, we have a group of 2, and then we have just 1 apple left. So to express the number 19 in base 10 as a number in base 2, the first significant digit is a 16. So we have 1. And then under the 8s, we don't have any significant digit. So we have a 0. And under 4s, that is 2 raised to power 2, we have another 0. Under 2s, that is 2 raised to power 1, we have a significant digit. So we have 1 here. And then we also have 1 on the unit place value position. So 19 in base 10 can be written as 10011 in base 2. This is how we represent the number 19 base 10 in base 2. Let's look at some examples. We are expected to express the following base 10 numbers in groups of 2s. We have 13, 37, 65, and 85. For 13 base 10, to solve this, that is expressing it as a base 2 number, we split the number in groups of 2s. First, we have 8, we have 4, and 1. Of course, when we put all these numbers together, it gives us 13. Now, 8 can as well be written as 2 raised to power 3. 4 can be written as 2 raised to power 2. And 1 can be written as 2 raised to power 0. So we have expressed this number 13 in groups of 2s. Now, 37 base 10 can be expressed as 32, 4, and 1. When we add all of this, it gives us 37. So 32 is the same thing as 2 raised to power 5, and 4 as 2 raised to power 2, and lastly 1 as 2 raised to power 0. Now to the third example, 63 base 10. 63 base 10 can be written as 32 plus 16 plus 8 plus 4 plus 2 plus 1. When we add all of this, it gives us the number 63. Now 32 can be written as 2 raised to power 5, and 16 as 2 raised to power 4, 8 as 2 raised to power 3, 4 as 2 raised to power 2, 2 as 2 raised to power 1, and 1 as 2 raised to power 0. Lastly, 85 base 10 can be expressed as 64 plus 16 plus 4 plus 1. And 64 is the same thing as 2 raised to power 6. 16 is the same as 2 raised to power 4. 4 is the same as 2 raised to power 2. And then 1 as 2 raised to power 0. So this is how we express base 10 numbers in groups of 2s. Now, let's look at some more examples. But in this situation, we are expressing base 2 numbers in the power of their base. We have some base 2 numbers and we are expected to express them in the power of their base. Of course, base 2. Now, to solve the first number, we have 1, 1, 1 base 2. So we go ahead and we write the first digit 1. So 1 multiplied by 2. And the second digit, we add and then 1 multiplied by 2. And then the last digit, we as well add 1 multiplied by 2. So from behind, we start numbering the powers. We start from 0, 1, and 2. So this number expressed in the power of its base is given as this. Now, the second example, 11011 base 2. So we go ahead, 1 multiplied by 2 plus 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2, and lastly 1 multiplied by 2. From behind, we give powers to the base. So we have 0, 1, 2, 3, and 4. So notice that whenever we have 5 digits as our binary number, the highest power will be a number less than the number of digits we have. What I mean is we have 5 digits here, and then the highest power is 4. Okay, I believe that's clear enough. So we have been able to express this number in the power of its base. Now, example 3, we have 1100101 base 2. So as usual, we go ahead bringing out each of our digits, multiplying them by 2, and adding all of them together. So we have 1 multiplied by 2 plus 1 multiplied by 2 plus 0 multiplied by 2 plus 0 multiplied by 2, 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2, and then we give our powers 0, 1, 2, 3, 4, 5, and 6. So we have expressed this number in the power of its base. Now for the last example, 101001. So we go ahead, 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2 plus 0 multiplied by 2 plus 0 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2. 0, 1, 2, 3, 4, 5, 6. So this is how we express this number in the power of its base. Very important, note that when assigning powers to the base, we start from the right end and assign 0, and then we count up to the very last digit on the left-hand side. I hope those examples were clear enough. I have an exercise for you just to see how well you understood my explanations. Do well to pause the video at this point and try out these questions. I hope you are done. For the first part of this exercise, it says express the following base 10 numbers in group of 2s. Number 1, we have 78 base 10. The answer is 2 raised to power 6 plus 2 raised to power 3 plus 2 raised to power 2 plus 2 raised to power 1. For question 2, we have 93 base 10. The answer is 2 raised to power 6 plus 2 raised to power 4 plus 2 raised to power 3 plus 2 raised to power 2 plus 2 raised to power 0. And for the second part of the exercise, express the following numbers in the powers of their base. Question 3, we have 100001 base 2. To do that, we start by 1 multiplied by 2 plus 0 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 multiplied by 2 plus 1 multiplied by 2 plus 1 multiplied by 2. And then we assign our powers 0, 1, 2, 3, 4, 5, 6. And for the last exercise, 1, 0, 1, 1, 0, 1. We have 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2 plus 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2. 0, 1, 2, 3, 4, and 5. So if these were your answers, you are correct. And yes, this is where we come to the end of this lesson. But before you go, let's look at what we've learned in a summary. First, we learned that counting in groups of 10 is the most commonly used system of counting. That is the decimal number system. We also learned that counting in base 2 means counting in groups of 2, and such a system of counting is called the binary system. Also, we learned that the binary number system is made up of only 2 digits, 0 and 1, and the value of the digits increases from right to left in the same way as the base 10 numbers. And lastly, we learned that we can represent binary numbers in the power of their base. We assign digits based on their position. For example, 2 raised to power 0, 2 raised to power 1, and 2 raised to power 2, and so on. Finally, before you go, I have some test questions for you. Try out these questions. Arrange the number 23 base 10 in group of 2's. A. 2 raised to power 4 plus 2 raised to power 3 plus 2 raised to power 1 plus 2 raised to power 0. B. 2 raised to power 4 plus 2 raised to power 2 plus 2 raised to power 1 plus 2 raised to power 0. C. 2 raised to power 3 plus 2 raised to power 2 plus 2 raised to power 1 plus 2 raised to power 0. And D. 2 raised to power 4 plus 2 raised to power 3 plus 2 raised to power 2 plus 2 raised to power 1. The correct answer is option B. The second question says, expand 11001111 base 2 in the power of its base. We have option A, option B, option C, and option D. The correct answer to this question is option A. Thank you for your time. I hope you now understand how to count in base 2. Till we meet again in another mathematics lesson. Bye-bye.